We don't have a channel name yet.
Okay.
Yeah.
Dot. To be confirmed.
To be confirmed.
Yeah.
Right.
TBC.
My name is Chido. I'm a geotechnical engineer. So basically, anything to do with the subsurface. I'm here with.
I'm Antonia. I'm an underground structures engineer. So still underground, just working on the structures. Tunnels mainly. Cut and cover, box structures. Yeah. But mobility so far in my career, but we'll see where that goes.
That's good. That's good. But you know what they say, right?
What do they say?
You're an engineer before you're a structural engineer.
I'm an engineer before I'm a structural engineer. Tell me more.
A civil engineer.
A civil engineer.
A civil engineer.
Okay.
So, which means you know a little bit about like structures in general, like building structures.
Okay.
Yeah. Bridge structures.
Okay.
A little
bit.
Okay, me too. Like a little bit, not too much, but
depends who you talk to. Apparently, underground structural tunnel engineers is just a hole in the ground. So I think it's so much more than that. But maybe you could, I don't know, Jude.
Yeah, it's just a hole in the ground. Like anyone can do it.
Even for someone who's in geotech, you still think it's a hole in the ground. The world of the underground.
It's complex. It's complex. I mean, like tunnel engineering, I think is one of like those civil engineering disciplines that are like really complex because of the inherent uncertainty of subsurface, right?
Which is your cup of tea.
Exactly.
Which I respect. That's why I respect what you do.
You're right. It's like, like the geotechnical investigation that has to happen when it comes to tunnel construction. It's not even enough, because you cannot dig like holes for, let's say, a 4-kilometer tunnel.
Yeah.
It's not like you're going to dig holes each and every 10 minutes.
Mm-hmm.
So, which means like you have to design your tunnel based on the geotechnical information that you have, no matter how limited it is. So, if this makes you feel better, I personally don't think tunnel engineering is just digging a hole in the ground. Yeah.
I always like to say I love the space because you're not just working with like an above ground structure where you're building the structure. You're working with a system where your support's coming from the same place that's could also potentially cause the whole tunnel to collapse in itself. And so that ground soil interaction, understanding sort of how that works and trying to model it and understand it in a varying conditions with lots of uncertainty on your end. It's a whole world, it's a whole system, it's a whole, I don't know, I think it's really cool.
Yeah, I don't think. I think geotechnical engineering is the only thing which is good. Tunnel engineering, it's right there. I'm just messing around. Yeah, I think it's really cool. But I think they work hand in hand, right? It's one of those things where like you need each other, right?
100%.
Right. It's like there's no. If you really want to build like a proper safe tunnel structure, you need geotechnical inputs, like
everything.
Right. Then you cannot do a tunnel if you only have like geotechnical knowledge, because it goes beyond that. I think you have to understand like strength of concrete, the type of tunnel that you want to, the method of digging, right? Tunnel boring machine, or what do you call it? Dig and blast, or
drill and blast.
Drill and blast. Yeah. Like drill and I don't know. Like you can go a little bit more into it. Like what's the difference between the two? And so let's say, for example,
in which asking me technical questions now, are you?
I mean, like we can go deeper. I don't mind. I don't mind. Like a free lesson about.
Even when I think about my experience today in the tunneling world, I've done a little bit in segmental lining, so TBM tunnels.
Okay.
I've done a little bit in cross passage design, but permanent lining design, and the most of my time I've spent on a single single project doing a cut and cover structure, and the methodology behind all three of them in itself is, yeah, okay, cool, reinforced concrete, awesome, because they all happen to be permanent design, but permanent lining. But yes, you're right, they're all completely different. The considerations for construction on TBM, segmental lining, yeah, okay, it's the same segment, whatever you can say,
Yeah,
but
just make it in the factory. They're like precast, right?
they're precast.
You just bring them
Yeah.
and just line them and lock them and you move to the next stage. No, I'm obviously oversimplifying it,
well,
but
to be honest, it's not my favourite area of tunneling. I'm definitely more into the mine tunnels, or even the cut and cover experience has been really, really cool. The cut and cover specifically because it was a single pass cut and cover structure, so there was no temporary works involved at all. We went straight to permanent design.
Okay.
Which is, it's been...
What does it mean, like cut and cover, right? Like, is it from the top?
So you can do top down or bottom up.
Okay.
This one was top down, and pretty much it's actually really cool. It's diaphragm wall structure, the one I've been working on.
Right.
Yeah, and so I don't know if you've seen like tremie pours and like diaphragm walls and stuff. Yeah, you've seen that sort of thing. Yeah. But then we construct the main permanent structure as we actually excavate down. So we dig the depth of the roof slab first, pour the roof slab, and there's openings. Then we dig beneath the roof slab and then pour the next slab, and then dig beneath that slab and pour the next slab, and create the structure all in a single pass, no temporary works.
Okay.
And I think that's the first longest one that's happened. Well, definitely in Australia. I can't remember if it was larger than that. But the complexities behind it, because we're working with a permanent structure, so construction, anything damages happening through construction, any risks, anything, this is the permanent structure. We have to consider that this is supposed to be standing for 100 years.
Right.
So yeah, it's been really, really interesting. Like no temporary struts, no like temporary diaphragm walls before the permanent. Like it is what it is.
Right. So like from the little knowledge that I have about that cut and cover, especially the one that you described.
The cover is we cover it. So, we dig the hole.
Right. Usually you cut open, then you cover.
And then you cover,
Then you have like this open space area.
Yeah, and then on top, whatever needs to go back on top goes back on top.
Right.
Sorry. Every no context to the cover part.
Right. Like I have enough, like a little bit of like knowledge about like how it works, and I think it's mostly used for subway stations. Underground subway stations.
Mainly, generally, the sort of where you see it most probably is in the portal sections. Like yes, for subway stations, but if you have to dig 30 meters underground, you're probably not going to do like to the roof slab. You're not going to do cut and cover. You have to dig before you even hit the structure. So it's the portal structures from above ground to sort of below ground that you probably see it most.
Okay. So like basements for, let's say, box basements, like underground basements.
Yeah, so like the metro stations, which are a bit shallower. Yeah. Like you can do that sort of
You can use that method.
Shallow underground structures, if that makes sense.
Yeah, it makes sense. What about the drill and blast?
I haven't had much exposure at this point. I really would love to do some mine tunnels at some point. Do temporary works.
So like, mining tunnel and drill and blast is it's kind of like the same thing, I guess. Or it's the most common method used in mining tunnels. Because I would think that like a tunnel boring machine, right, is more effective in boring through softer materials. So like sandstone, claystone, but not as effective or efficient in maybe intrusive rocks, like igneous rock, like hard rocks. I don't know.
There's been actually like a huge push towards TBM tunneling in the industry as a whole, from my understanding.
Okay.
Because it is very efficient. It's kind of the safest form. You don't really need, like, any sort of mine style tunneling, whether it's drill and blast or whether you're using road headers or whatever style of underground digging you're doing, like, it's obviously there's more risk.
Yeah.
TBM installs as it moves. You only need an operator in the
It's
machine.
like an industry. It's like a moving industry, right?
But you're restricted to shape. You're only going to get circular shape, and we haven't really explored beyond that. You're not going to see many stage. Like,
I've seen a box one.
Sorry,
I've seen like a box TBM.
have you?
Yes, it was used in Hong
even
Kong.
seen it.
Yeah, it was
Yeah.
used in Hong Kong. I'm forgetting the
Yeah.
exact location of the project, but they used it for cross passageways.
Cool.
So at an intersection of highway, freeway roads, they wanted to go underneath, and they couldn't use like a circular TBM because it needs like a longer turning radius.
Okay.
So it's a box TBM, but the cutter headers, it is like many cutter headers in front, and it just goes through and it moves itself, just crawls.
So it didn't rotate, it just pushed through. Is that what you're saying?
It just pushed through. So the cutter heads are the
It
ones
was a
which
cross
would.
passage.
Yeah.
And did they just like remove the soil from the other side?
Yeah.
That's interesting. I haven't seen that.
Yeah. You
That's
should look it up.
Yeah.
Yeah.
Using
I'll send you a link
Yeah.
about that project.
Using
Yeah, it's
sort
quite
of-
interesting.
they're definitely starting. I've seen more TBMs being used for cross passages, like micro tunneling, smaller TBMs.
But the cutter head is
But
like
I
one
haven't seen a
solid.
square one.
Right.
That's cool.
Right.
Just
But
push.
but this one is like it's like rectangular in shape.
Yeah.
But then the cutter heads, right? It's not like one singular disc like in regular tunnel boring machines.
Yeah.
This is made of like small individual cutter heads, and
Like just different square ones, like
no circular.
but it forms a.
Right.
Oh, okay.
But it covers the whole area of the swing.
Okay.
Yeah.
This makes more sense. I'm like, well, how is it like breaking the soil? I was just a bit.
All right. It looked like it was like a whole,
I was just
like a square of cutter head. Yeah, but yeah,
That's cool.
yeah, quite interesting. I think I'm gonna make a video about it on my other channel.
Please do.
So yeah, and about the drill and blast.
Yeah.
So that's the one like which uses spray concrete liners, right?
Yeah.
Yeah,
Shotcrete. Yeah.
shotcrete.
Yeah. Contemporary.
But
Sometimes.
permanent. I
Yeah.
think. Right.
Yeah.
So reinforcement, like shotcrete. Then a liner for waterproofing.
Yeah.
Then reinforcement cage. Then
I love it. He knows what he's talking about.
a little bit. Then shotcrete again to cover,
Yeah.
the final lining. Then,
Obviously, it depends on the conditions of the ground itself as to what it actually looks like. If some cases we need actually like to create reinforced permanent lining.
right,
Depends on the conditions, and might be you need rock bolts.
right.
The sort of support you need depends on you godly guys and the investigations.
Yeah,
You guys
of course.
do.
I told you. There won't be you
Yeah.
without us.
Yeah.
Yeah.
Well, that's why I really like this ground, this area, and I haven't had experience in it myself. But what do they call it? I can't even remember.
No,
The sort of
geotechnical investigator. You see, that's why we don't like tunnel engineers. No, I'm joking.
the sort of style of tunneling where it's very much like the type of lining we select is based on what we see as we start to excavate. And that's really, really cool approach, in my opinion. It's
it is.
to tunneling,
I think so too.
which relies on geotechnical inputs, obviously.
Yeah. I think it's it's one of those things that as I was saying before, like we work hand in hand, right? It's like you need like geotechnical inputs, even for structural design of the tunnel elements as well, like whether permanent or temporary, right? You need like parameters like rock strength, soil strength, like the shear strength of the soil. You need to understand like the joints. What kind of joints are they? Do you need to do rock bolting to to keep it together, basically, right?
It's cool.
Yeah,
Even the fact that you can create models to see where fractures and failure zones are in the soil, I think is really, really cool.
that's actually interesting.
It's
That's
so cool.
it's called like geophysics. Yeah,
It's amazing.
yeah. It's more like scanning the ground, or like using geotechnical data input to develop a cross section model, like geological model, to map out like the whole length of
It boggles my brain how you still manage to do that with so little borehole data, and yet
that's why it's not accurate.
Yeah, but we rely on it from a structural design perspective.
Yeah.
We rely on that profile, so I think that's why I like the structural side. But
a little bit jealous about.
I appreciate what you guys do.
Yeah. And speaking of not having enough geological data or geotechnical data, brings us to this video that I wanted us to react to.
Okay.
So, what a transition.
Yeah, that was golden.
Right?
I forgot about the video. I was like, what are we doing?
Me too. So, the background of the story, I think I sent you.
I totally watched it. Yeah, I watched it.
Yeah, but anyway, I'll just give you like the background of the story behind.
Okay.
So, it's the Millennium Tower in San Francisco. So that's West Coast.
Okay.
I think. No, I'm sure. It's
I
West
believe
Coast.
you know what you told me.
It's West Coast, and it's an apartment building, like a multi-million-dollar apartment building, like the project, multi-million-dollar project. I think the units in this apartment block, they are going for like some of them, like the penthouse, like $1 million plus.
Fabulous. Thanks.
Yeah, I know, right? I know, right? And I think
US dollars.
Yeah.
Yeah.
Yeah. I know, right? Yeah, it's
Yeah.
They finished construction of this apartment block back in 2009, I think.
Okay.
But then it has been sinking and tilting.
So a second Leaning Tower of Pisa, or?
Exactly. So they actually call it like the Leaning Tower of San Francisco.
That's beautiful.
I know.
Hey, well, the Leaning Tower of Pisa is still standing, so...
Right.
Yeah.
Yeah. So
it's a monument now.
Now it can be a monument.
Okay.
Right. Except that...
It still... Sorry.
No. Go ahead.
Is it still sinking?
Yeah, that's what you're going to find out.
Okay, I was like, let's watch the video.
Okay.
Have they remediated? Have they found a fix?
They're working on it. I'll not spoil it for you.
Okay, wait. Is the Leaning Tower of Pisa still sinking?
No, the Leaning Tower of Pisa, they found a solution for it.
Okay.
Yeah.
But not this one. Okay. I'll watch the video.
Yeah.
Tower is back on tonight. Building officials just gave the green light for limited work to resume. Good evening, I'm Ken Bastida.
And I'm Elizabeth Cook. KPIX5's Max Darrow spoke exclusively with a former condo owner who decided not to wait around for the outcome. Max?
We've been reporting on this for months. The fix to San Francisco's leaning Millennium Tower has made the problems recently worse rather than better. The building's now tilting 25 inches to the northwest side of this heavily trafficked intersection of Fremont Street and Mission Street. A former condo owner tells us he's glad he got out when he did.
Well, it was packed.
Andrew Falk remembers it like yesterday, the day 5 years ago when he and hundreds of other unit owners in San Francisco's Millennium Tower were called to an important meeting where they got what would become life-changing news.
Well, the best I remember is the building is sinking and tilting.
Homeowners learned their luxury high-rise had sunk more than a foot and was leaning to the northwest.
What they said was, this is not a big problem.
Are you laughing that the building is sinking, or it's because people had paid a lot of money for a building which is sinking?
I'm just imagining the conversation of, hey, these apartments you bought, well, the whole building's just sunk a foot to one side, if you don't mind. That's fine. But it's okay. We'll figure it out. We don't know why or how to fix it, but we'll figure it out.
Plus, it's only $1 million, right? I mean, like, you know.
Okay, wait. Is this video going to go into how they, like, when they realized, how they realized?
Oh, yeah, kinda. I think so. Okay, I'm not gonna spoil it for
I'll
you.
wait
But
till you see
if
it.
it doesn't come up in this video that you're watching, I'll tell you how
They
the whole
just-
thing went.
Was it Doctor was just cracking the concrete? Anyway, I'll watch.
Alright, yeah. Oh yeah, did you see like the cracks on the pavement?
In
Like,
the side of the
in
building.
the side of the building, it's just like, you know, it's a hanging piece of from $1 million apartment.
Had sunk more than a foot and was leaning to the northwest.
What they said was, this is not a big problem.
Later, Andrew's husband, Frank Jernigan, rolled a marble on the floor of their $4 million 50th floor condo that confirmed for them the problem was all too real.
The marble turns around and picks up speed as it heads in the direction that the building was leaning. We were surprised.
But then they started connecting the dots with things they had noticed soon after they moved in. There was a problem with the pool that straddles the Millennium's 2 towers that had to be fixed.
The flooring between the 2 levels, one sank and the other didn't.
Growing cracks in the sidewalk, and the most shocking, what the couple discovered when they visited the lowest part of the garage. Water appeared to be seeping through the concrete walls, and huge chunks of
Wow. What do you think so?
I have so many questions. I just want to say this to the end.
Right?
What is going on? Is that the inside of the garage?
Yeah, this is the inside of the garage. Remember, you were talking about cutting.
Completely exposed.
We're talking about cutting cover, right? After you do your basement using cutting cover, to create something like this. And I don't even think like this reinforcement is actually enough. If this is a retaining structure, the thickness of this reinforcement, I don't think it's adequate.
So many questions.
Right? Even like the
But that
spacing
spacing is
wrong.
ridiculous, yeah.
Yeah, right?
So
With the connection.
surely it's not retaining. Like, I don't know what it
I
is.
hope it's
I don't know
not.
where it is or what it is. I don't
Right.
know.
I hope it's not a retaining structure. I would hope so.
of walls seemed to have crumbled away, even though the building was only 7 years old.
Did they ever disclose anything when you bought this unit in 2011?
No, that was really disappointing because we learned that the sinking had actually already begun when they were showing the unit to us.
There was really a lack of transparency in the early days.
David Williams is a structural engineering consultant and deep foundation expert. In 2017, other concerned unit owners hired him as a consultant.
There was evidence of a lot of places with water intrusion.
Williams also noticed extensive water damage in the garage, but he says the floor of the Millennium Tower's basement exposed what appeared to be an even bigger problem. It was dipping in the middle, something referred to as dishing.
The dishing of the floor there, which is the dishing of the mat, 10-foot thick mat, was significant. Clearly, it had been distressed.
According to Williams, the Millennium Tower was originally designed as a much lighter steel high-rise. When the design changed to 58 floors of heavy concrete, he believes the foundation became inadequate.
The foundation was really designed for a lighter building, and they must have decided to either risk it or
So what they mean here is a steel structure is lighter than a concrete structure, like a reinforced concrete structure, because concrete is heavy, like it's really heavy. So apparently when they did like the initial design, they designed it as a steel structure. And so which means they designed the foundation, right? With the weight of a steel structure. But then somebody thought it was a good idea just to, you know what, let's change it into a reinforced concrete structure.
Surely no structural engineer or engineer would make that change and not check.
Yeah.
Or reassess. Like, no, surely not.
I hope so.
Surely not.
Right? But okay, let's finish the video, then we can discuss
What was that concept you called? What did he say the foundation was doing? What did
Oh, it's dishing.
dishing?
Yeah, dishing. Which is kind of normal.
Okay.
Yeah, like to some extent, like some settlement is acceptable, right? But excessive settlement is bad.
What I'm imagining is the actual. It's like a.
Yeah,
okay.
so at the center of the basement slab.
Yeah.
It's like sagging.
Yeah.
Yeah.
Convinced themselves that it would work for the much heavier building, but clearly they pushed it past its limits.
It's something that's also been on Supervisor Aaron Peskin's mind.
The building today is not in any imminent threat of structural failure. The question that has not been satisfactorily answered, as far as I'm concerned, is at what point is the point of no return?
He has scheduled hearings on the matter at City Hall.
The city must demand that there is a well-thought-out plan for retreat and dismantling of that building should we ever, God forbid, get there.
Andrew and his husband were among the first to sell their luxury condo in the Millennium Tower back in 2017.
The anxiety just grew and grew and grew. If there's a quake, we felt unsafe.
And they've since moved on. Andrew's focusing instead on a memoir that was just published of his life as an HIV doctor during the AIDS epidemic. But he hasn't forgiven.
We're left with this feeling that this whole thing, it was unfair. It's not fair to sell people these units and not disclose what was going on. And we know that's illegal, but they got away with it.
A spokesperson for the HOA sent us a copy of a letter from a contractor working on a leak repair design for the garage. According to the contractor, the ongoing water intrusion problem in the garage, which is in the second tower, not directly underneath the main structure here at the Millennium Tower, does not pose a life safety concern.
Well, Max, you mentioned some hearings next week at City Hall. I can't imagine that they're going to sidestep these questions about the foundation.
I'm sure we'll learn a lot in those hearings, Ken, but the engineer we spoke with said he hopes that there is a complete assessment of the building's foundation that is addressed during those hearings, and he even argued that he thinks that should be done before the current fix moves on. We'll have more on that at 11 o'clock tonight.
All right, Max, thank you.
So, all those questions that you had, what do you think?
Have you done research into this? Into what they found?
Yeah. So there are more videos, kind of like following the whole thing which is going on. So there are a couple of other clips as well, where they were showing like the proposed fix plans that they have and that they did. So we can react to those in the next video.
Okay.
Yeah. But for now, like, what do you think so far?
They've said different things. Like, obviously, that was just a clip from very concerned people who've bought apartments, and obviously you feel empathy for them, and it's a sucky situation. Yeah, it sucks.
Yeah, sucks. From a structural engineering perspective, like, what do you think went wrong, and like what could have been done? What could have been? I know, like,
they flagged two things from what I could see. One was the leakage, and one was the foundation support, which they could be two separate things, could they not? Whether the additional weight from the building above is one thing, but
I don't know, did
that influence the water?
Yeah, I think so. I think like there are two possible reasons for that leakage, right? Two possible cases, at least like the ones that I can think of. It's either because because the building is sinking and shifting, there might be some deformations on the structure itself, so it's causing cracks. Because I believe that, like, in this, like, I think it's in the Bay Area, so mostly it's sitting on close to the coast, and the water table is relatively high. So when you're doing like foundation work, especially basement work, waterproofing is one of the things that you have to consider.
I guess if the settlement caused the cracking or failure to the waterproofing membrane or whatever may have caused the issue itself. What happened? Is that not a ground thing as to what causes a settlement to be differential but on either side of the foundation? Like, I don't...
Yeah.
This is where my understanding of it kind of...
Okay.
So
when it comes to the sinking of the building, number one, like, before we even go any further, this building was supposed to be bolted on bedrock, but it wasn't.
What do you mean?
So
how was it not? Like, what? Yeah,
I know, right?
Like, what?
Right. So you'll see, like, in our next reaction, we will talk more about, like, the foundation mistakes that were made, because there are a lot. Considering that this area of San Francisco, right? If you look at the geological map, most likely it's sitting on reclaimed land.
Okay.
So it's like new material which hasn't consolidated and gained strength. So it's like trying to build a foundation in yogurt, like coastal swamps, and and with a high water table.
This is me trying to imagine it now. Like, where's the bedrock actually start in beneath the ground surface?
It varies.
Okay.
Yeah.
Okay.
It varies. So basically, right, when it comes to geological layering of materials, right? So you might have, in this area of San Francisco, it's closer to the coast. So it's like a depositional environment, right? So throughout time, right, and the formation of earth, right, and throughout time, it changes. The depositional environment changes. So during colder periods, right, the seawater is stuck in the pores, right? So during the ice age, the seawater is stuck in the pores, which means the seas resides, right?
How are you trying to say? Yeah.
Recedes.
Recedes. That sounds better. I don't know. Anyway,
yeah, recedes, right? Recedes, right? So there's no like depositional. There's no like deposition of materials, right? So you have a different formation from rivers flowing from inland and to the sea, right? So different types of materials get deposited on the shores.
Yep.
So we have materials from inland, which from different origins, different rocks, mountains, different places. But then during warmer seasons, right, that water is released from the pores. Then the sea level rises. Then the depositional environment changes. Now,
this is why I think geology is really cool. So you kind of see like your river deposits with your sort of sea deposits and the river deposits.
Exactly.
That's so cool.
That's so cool, right?
That is so cool.
Right. So
seasonal as well.
It's seasonal as well.
Yeah.
So you end up with layers of different materials.
Is there periods, and this is just me curious now, can you even match that to temperature changes and actually see like thicker river deposits when it's been colder?
Right.
Can you see stuff like
exactly.
that?
So
That's
this is
cool.
actually one of the methods that they use to do carbon dating and trace back different periods of Earth's history.
Yeah.
right? Because each and every layer now has different organic materials from that time, which are just stored in there. So you have shells, right? Then you have bones from different animals which were deposited in this layer. Right. So through carbon dating, you can tell which age.
I was going to say, yeah, the soil tells the story.
The soil tells the
so
story.
Cool. That's so cool.
Right.
I do appreciate that.
Right. And another coolest thing is you might find rock as well, because a volcano and lava flow.
Yeah.
Right. Flows, then it covers on top.
Yeah.
Right. So in the case of San Francisco,
is there actually volcanic activity somewhere around this area in the past?
Yeah. Yeah.
So there are like
basaltic, like more volcanics. Actually, they're relatively new considering how old the Earth is. This area that we're in, yes.
That is cool.
Yes.
That is cool.
Not even a long time ago. Quaternary age.
Cool.
Yeah, so it's, that's like the most recent geological period.
Cool.
Yeah.
This is really cool. Really cool.
Yeah. So, going back to my point of like, so literally this building was supposed to be anchored on bedrock. But they didn't. They just used frictional piles.
Interesting.
Yeah.
Interesting. And they consciously knew that they hadn't hit bedrock? They knew, they made the decision, we haven't hit bedrock, but we're going to leave it anyway?
Yeah, we're just going to suspend it, in that...
That's the same sort of silliness of just saying, like, oh yeah, we're going to just put concrete. Who cares if it's heavier? Let's just leave the foundation.
Right.
That's the same concept.
Right.
It hasn't quite hit the bedrock yet, but we've designed it for bedrock, but who cares? We'll just assume that the skin friction's enough.
Yeah. Yeah. Yeah.
Surely they did checks.
Yeah, I think so.
On both ends.
I hope, to be honest, like, I hope so. I hope
so.
They did do checks and, like, due diligence and, because it's kind of like a rookie mistake, I would think, considering that, like, it's such a big project and, projects like these are usually awarded to experienced firms, and you have multiple people who are working on these kind of projects. It's not graduates, right? I'm sure, like, they were not graduates.
Wait, so has the differential sediment happened from some of the piles being in bedrock and, like, hitting bedrock and some not? Or has it happened because it's all just hasn't hit the bedrock and it's just the differential from the soil sediment itself?
Yeah.
If that makes sense.
Yeah, it makes sense. So for example, right, you can have, number one, it can be from the weight distribution of the structure itself. So one side might be a little bit heavier than the other, which means that side is going to sink faster than the other side, right? Of which, like, a properly designed building is supposed to settle equally.
Yep.
Yeah, and you can actually calculate this, right? Like the settlement, right? There's an acceptable settlement that you can actually calculate, and ahead of time that our building is going to settle this much in this period of time. So you can maybe do some preparations on, like, how to shift services, because if let's say it settles with for like 10 centimeters, I don't know, like, how you Americans convert 10 centimeters to inches. I don't think I can. But, like, 10 centimeters is
low-key jab there.
It's like this, big, right? It might be, enough to put some stress on pipes. And,
I definitely appreciate settlements. Obviously, something that it's in all infrastructure that we look at. I guess understanding how this happened, I'm just curious what was missed. Was it a construction thing? Did they not build to design? Was it a designer thing where we didn't consider some sort of loading, or was it a ground thing where we missed some sort of discrepancy in the ground conditions that caused some Well, even then, was the settlement overall bigger than expected, or was it just that because it was a differential settlement that caused the issues? There's so many questions I have to even begin to understand what we're, that's where my brain goes. And you know what I mean?
And you're right to think like that, because this one left you with I can see it left you with
I don't know.
It's suspense.
Because of course the structure failed if we didn't account for such surely they didn't design knowing that much it was gonna start tilting. Of course it was gonna added stress. Added stress is not accounted for.
Okay, so I think,
you know what I mean?
yeah, because for me, like when I first came across this
so many questions.
This case, right, I was like, how, right? It's one of those things where I was like, how? Because even from a geotechnical perspective, right, before we even go out to do like an investigation, site investigation, we do like site history study. So basically, you go through like geological maps. You go through like what kind of buildings, right? Like what kind of like infrastructure was there before, right? Surrounding infrastructure. These are like all important because they paint a picture. They can tell you in advance like what to expect, right? Or what you're going to come across. And the idea that like people designed this building, then the contractor came and constructed this building without questioning as well. Then the city council approved the designs, then approved the building.
Do you know much about how infrastructure, the review process and whatnot around infrastructure in the States? Because obviously I've only had experience in Australia. Do you know?
I don't know how it really works, but I would assume because these are like the basics, right?
Yeah.
These are like basic chain of like review.
Yeah.
That's how that happens
Yeah, obviously from the Australian perspective, it would suck to say I went through that many reviews and it still failed.
Yeah.
Yeah. Or where have you doing this sort of work as an engineer, being like an investigator engineer, whatever their title's called, would be actually really cool, I think.
Yeah, because those guys were just sitting there and be like,
it'd be cool. Trying to understand, it could be any of these number of problems.
Yeah. It's called like forensic.
That's what I was looking for. Forensic engineering.
Forensic engineering.
That'd be cool. You just go, all right, so how the hell do we check which one it actually is? Or is it all of them? Or is it part how
then
cool?
You do like back analysis and to figure out like what happened.
How cool. And you need like a very holistic understanding because it's not... I hate to say where you're going to point the finger, but they'd be looking to where to point the finger because who's going to pay for it?
Yeah.
I'm assuming. Because you can't talk to any of the disciplines because they'll all go and point the finger to someone else.
Yeah.
So it's like
no one would want to take responsibility.
No, why would you not? Why would you want to?
Because someone is losing money. Because I think this type of mistakes are the kind of mistakes that even like your insurance will be like,
Yeah. But even to the level, and this is where it starts to get grey, where you're just like, okay, I designed this, but everyone else also reviewed it and didn't notice, didn't notice it either, or didn't say something either, or they...
It might have been people trying to cut corners. There's a possibility that somebody...
It's a can of...
Yeah. Right? Because I think...
Time, I don't know.
I'm sure like a graduate somewhere pointed it out. I was like, I don't know about this. And they were like,
maybe?
Shut up. You don't have experience.
Maybe. Or I shouldn't say that. I won't say that.
Go ahead. Speak your mind. Speak your mind.
You never know.
Yeah. But I'm sure someone in the office, right, pointed it out. Yeah.
I freaking hope not.
I think so.
I hope that it wasn't pointed out and ignored. That would make me feel even grosser, personally.
Yeah. Well, it would be one of those things where, like, the client maybe doesn't want to pay a little bit extra.
Yeah, my perspective,
Yeah.
whether it's time or money, always seems to be a driving factor in my experience.
Yeah, it's usual about money,
It's
right? Because it's like, then if you add a couple of $1 million, then we just have to drill to bedrock. But then you have a really good structure. Then the client is like, but is there any other way?
I want to see that. That's
Yeah.
and then
Right.
well, I don't think we've quite figured it out in Australia.
I think it's a alleged. Allegedly.
We can cut some things out of here, right?
Allegedly, I think it's a worldwide problem.
Is it?
I think it's just worse in other places than others.
Oh, yeah.
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 But, people want to make profit as much as possible.
Which I get.
Right. But
At what expense?
at what expense, right? Because I think it's one of those things where there's always consequences to, to decisions like this. So downstream effects.
This
Things
seems
might
like a big one, though.
Yeah.
Designing, I haven't seen what the thing was, but you're literally saying that the whole system. Am I being silly? You're saying it was literally designed to have pile depths to hit bedrock, and they didn't hit bedrock, so they just stopped it. They couldn't be bothered, going deeper.
No, I think that's what they should have done.
They underestimated the depth of the bed.
It said because the foundation design was enough for a steel structure, but then they changed it into a reinforced concrete structure, which can be maybe 2 times heavier than. And then they were like, it's not exceeding, right? It's like, okay, the load is not exceeding the bearing capacity of the power foundation, but then maybe it's close enough. Maybe the safety factor is like 1.3. Then you're like, yeah.
Are you saying
it's not 1.5, but 1.3, it's okay.
But are you also saying that led to the load distribution was off as well?
For the tilting, right?
Yeah.
Yeah, for the tilting, maybe it's because the load distribution.
Sorry.
That
was the key problem here, and for this was it?
The sinking as well.
And the sinking.
Right. So
not just the tilting.
Right. So no, the the tilting
Okay.
is icing on the cake. It's literally sinking. Then the tilting is just to spice things up.
It's different sources of failure in the structure, whether from the tilting and the sinking. But it's doing both.
It's doing both.
So it's crushing and bending.
Yeah. Oh yeah. The tilting is just for dramatic effects. The leaning part.
If it was just sinking and not tilting, the residents would probably be less scared, except for the water failure stuff. But if that was
I would be scared. I would be scared. Considering, knowing what I know, I would be scared because, so that San Francisco sits on the Ring of Fire, right?
Go on.
So, Ring of Fire is
Oh yeah.
Right, the Pacific Plate.
Yep. Yep.
Right.
Yep.
So basically, the Ring of Fire is the plate tectonic movements. So the Pacific Plate, I think it's.
I don't know which one
subsides. Yeah, I think it goes
I'm not sure about that.
in the North American continental plate. Basically, it sits on a earthquake active zone, and in those kind of materials, geological materials, there is potential for liquefaction during an earthquake. Yeah.
Have you done a video on that before?
Yeah, I did.
You need to direct me to the video.
Link in the description. Link in the description if you want to understand what soil liquefaction is. I'll put the link. I'll put the link in the description for my video. Yeah, there's potential. There's potential of that because it's an active zone, right?
Yeah.
So, U.S. West Coast, then it goes around Japan, then it comes down Taiwan, Philippines, then the South Pacific Islands, then New Zealand, then it goes across to Chile. Is it Chile, Peru, or Peru, Chile? I don't know my Latin friends. Yeah, Chile, Peru, right? Yeah. Then it goes back. So that whole area is like a seismic active zone. And for a building like this in downtown the city, it would be wise to make sure that it's anchored on bedrock. Because, okay, just as a teaser, if an earthquake happens and in that kind of material, there's potential that the material, right, the ground material will behave like fluid. So basically, because of the shaking, it suddenly loses its strength. So if you notice, like after earthquakes in areas like Japan, Jakarta, Indonesia, there are some buildings where like the structure itself, right? The structure itself is still intact, but it just sinks in.
Do you show them in the video? Because it's just definitely something that's so much cooler seeing.
Yeah.
It makes so much more sense when you actually see, like, it literally turns into a liquid and then solidifies as soon as the vibration stops.
Right.
It's just so cool.
Yeah, it's like quicksand. It's like a
Cool to
quicksand.
play with. In this scenario, maybe not.
Right. So yeah, I don't know. I think our video went longer than we had expected. But I think it's
I'm
good.
sure we're going to cut things, right?
Yeah, I think so. I think we'll cut some things, but even I feel like there's not much to cut.
I'm sure there is.
Yeah.
Some maybe beginning rambles.
Think so?
I really want to know.
Do you think we're waffling too much?
I waffle big time.
Yeah.
But I really want to know what happened, what they did wrong.
Okay. So yeah, thank you for watching. This was our first video. So
at TBC ...
Exactly. we don't have a name yet, but maybe by the time we upload this video, we will have a name.
Okay.
For the
I'm
channel.
kind of just digging TBC.
What is that? What does that even mean?
To be confirmed or TBA. To be advised.
Okay. To be confirmed. Okay. I'll put that down. Alright, so yeah, thanks for watching. I think for the next one we'll do a continuation of the Millennium Leaning Tower of San Francisco. Yeah,
I didn't realize we needed another one, but that's cool.
Yeah. Then we can just do a series. A series of this.
Okay.
Because you seem like you have a lot of questions.
I have so many questions.
Yeah. And we haven't even touched on like the fix. Right.
I still want to get to the cause.
Oh, okay. So good then.
So many questions.
It makes it easier to find things to react to. We have a lot to react to about only this. All right, guys. We'll see you in the next one.
See ya.